Hey everyone, welcome to this new video where I'm gonna show you how to receive payments on the XRP Ledger, but also how to verify that the transaction has been validated on the ledger. So in my previous video, we saw how to send a payment, and we used the client to submit and wait. And this wait function in the background is really checking for some things that we're gonna see today to make sure that the transaction is validated in the ledger. So what does that mean, validated? So we have this Explorer, for example, this is mainnet, and you can see that the payments or the offer creates everything the ledger allows is included in a ledger with a sequence number. So you have 56, 57, etc. And so what we want to check again is how to make sure this the transaction we submit is in one of those ledger. I'm gonna actually copy this code and write it in another file. That's what I already did here with this send payment and wait TypeScript file. And I'm gonna first do like a little change, just also to show you another way of having a wallet. Instead of using the client, I'm gonna use the wallet class that is provided by XRPL.js. So let me actually delete all of this. And I'm gonna initialize constant sender equals wallet. That's again provided by XRPL. Dot from seed. All right, so that way I'll be able to reuse the same wallet again and again instead of creating a new one all the time. And same thing for the receiver. So constant receiver equals wallet from seed. So we're going to take that seed from a .env file, which I've created here, .env. So we have a seed1 and seed2 key. And to get those seeds, we are going to use the faucet provided on xrpl.org. You choose the testnet, you generate your credentials, you copy the secret here, you paste it, for example, for seed1, that will be the sender. You go back to the faucet, you generate again credentials, you copy the second secret, and you paste it here. So we have two accounts now. Sender, receiver. Going back to send payment and wait. And before the sender and receiver wallet, we can just extract the seed1 and seed2 from process.env. Seed1, we initialize it to an empty string in case, and seed2, same thing, empty string. To be able to read from the .env, we need to import .env from .env, and we need to initialize it. So .config, like this. And we should be able to now read from the .env file. And finally, the from seed function here will pass the seed1 for the sender and the seed2 for the receiver. All right, let's see if that works. I'm gonna, of course, update my index.ts and use the send payment and wait function instead of the send payment. And now I'm going to run npm start. So this is going to submit only the transaction to the ledger. That's a submitted transaction, but that doesn't mean it's validated on the ledger yet. And I'm going to show you how to get that in a minute. If we go also to an Explorer, let's have a look quickly at the Explorer. We can look at the sender account, and we see we are sending some payment, 15 XRP here, which is part of this amount. So after this submit, now let's do like apply a logic to wait and sort of validate the transaction. So I'm going to create this function here, constant wait equals async. I'm going to pass the parameter just after, but we need the transaction, which is a submit response of type submit response. This is what we get from this function here, client.submit. And I'm going to also pass the client because we're going to interact with the XRP Ledger. So the logic here is that we will extract the hash and last ledger sequence from the transaction. We will check that they are defined. We will check then, we'll get the last validated ledger sequence from the client. Then we will use a transaction method provided by the XRP Ledger, which is like a get method, sort of, to get like the transaction. And we'll check if the validated field from this response, from the transaction method, so from this response, is set to true. Okay, that's like the high level logic of this function. So first, let's do this extraction. We'll take the transaction and the result and the transaction.json. From there, we'll have the hash, potentially, and the last ledger sequence. So check that they are defined. So if we don't have a hash or we don't have the last ledger sequence, we can throw a new error in, let's say, no hash or last ledger sequence provided. Then we get the last validated ledger sequence from the client. So let's do like last validated ledger equals await client dot get ledger index. That's what this function gets us. So when you look at the Explorer again, let's do, I think I have this one, yeah, that's the mainnet. That would give us, for example, 569, 570, etc. And so here we check that basically this last validated ledger sequence is higher than the last ledger sequence from the transaction. And if that's the case, again, we are sure that the transaction will never be part of a ledger, part of a block. And so you can go back to your customer saying that your transaction had a problem, it's not validated, please submit again. So we can throw a new error here. Last ledger sequence has already passed, that's fine. Okay, those are like the first checks. But then let's go to checking the transaction itself. So we'll use a try and catch block. And the XRP Ledger provides a public method. So let's do transaction response. We'll use the client, and that would be the request method. So it accepts an object with a command, and the command is called transaction. The second argument is what we want to check for the hash. We want to get a specific one, get by ID, for example. So that would be the hash. So here we have, we are checking that if the validated field is true. So if transaction response dot result dot validated will return the transaction response. If not, we can just loop again and wait to see for the next iteration if the validated field is true. All right, I'll just add a catch block here for now. The error code here. Just before we run that, I want to add as well that I've added like a small helper, like a sleep function to sleep for X milliseconds. So I'm going to use it now. It's called sleep. So I'm going to wait 1 second, and that helper function is in this directory, helper sleep. Very simple function. So I have this. Let's have a look and run that function. So first I'm going back to my initial function called send payment and wait. And after the submit, I'm going to check the validation. So constant validated transaction equals the wait, and we just wait this one. We pass the response and the client. And when we have this validated transaction, we can console log the validated transaction. All right, let me clear the terminal. I'm going to run start. I increase the terminal. That's the transaction directly after submission without validation. We don't know yet. But then right after, you see we received the validated transaction here with the validated field set to true. And now we are sure the transaction is in the ledger, and again you can go back to your client saying the transaction was successful. One thing I would like to mention as well here is that in the catch block, if the transaction is not found, so that request will throw an error, we can catch it here, and we'll have two scenarios here. One is an object with an error message saying the transaction is not found, so transaction not found, something like that. And otherwise, if it's not this error message, then there is an expected error and we can return. So let's try to extract this transaction not found error. So we have, actually, let me show you before how it looks like. So I'm going to console log the error. So I will change the hash here. I'm going to comment this part, and I'm just going to use a hash for transaction, but I'm going to replace it. So instead of ending by C3A, I'm going to change it by C3B. So let me run this again, and we'll see that we'll have the error. That's just a submission, but then we have this error, transaction not found. So here, we'll try to extract this error message. I'm going to put it a bit bigger, my terminal. Let's try to extract this. So we have the error equals to error, actually, dot data. And here we'll just mark expect error, so there is no issue. Next thing, so we're going to check if the error is not a transaction not found error, and that's with an N. So if error equals to transaction not found, then we can again loop and use that wait function. If not, then we'll just return a new, like actually we'll throw a new error, something went wrong. Okay, that's the logic you would have in the catch block. I'm going to pass again the transaction hash. Actually, maybe I can run this function again. It's going to run again and again, but actually I need to just rename it. So let's do like error like this. And if error equals like this, okay, that should work now. Let me run again, npm start. Okay, so now it's like looping and again, but we'll never have the validated transaction simply because the hash is not valid. And at some point, we'll reach this if block here that the last ledger sequence has already passed. Okay, so the last validated will be greater than the one we defined in the transaction. Here it is. The last ledger sequence has already passed. And now that we are sure the transaction will never be included in the ledger. That was it. I hope that was useful. I hope you understood a bit the logic about the XRP Ledger and how a transaction is validated and what you need to do if you don't have access to this submit and wait function provided by the XRP Ledger, by the JavaScript SDK I meant. Let me know in comment if you have any questions, and see you for the next video.